All right. Welcome everybody to another OpenShift Commons briefing. My name is Beverly, and today we have Francesco from Red Hat's AI Center of Excellence joining us to discuss data-driven engineering and Project Thoth, which is actually one of the projects being incubated at the AI Center of Excellence. I believe Francesco has a demo to showcase later in the briefing. So without further ado, I'll let him introduce himself. And if you have any questions, we'll have a live Q&A session at the end. But in the meantime, feel free to add your questions in the chat wherever you're watching this live stream from, and we'll relay them back here. So with that, Francesco, you can take it away.
Thank you very much, Beverly. I hope you can hear me correctly and see the slides. Is that yes?
I can't see the slides right now.
Okay, perfect. So
cannot see the slides.
You cannot?
Yes. No, cannot see the slides. No, sorry.
Is it like this correct?
Nope.
No.
That's yes.
OG refresh. Are you using the browser by chance?
What about now?
Good.
Yes. Perfect. Sorry. Thank you very much, Beverly. So, hi everyone. My name is Francesco, and I'm part of the AI Center of Excellence, and I work on Project Thoth. I'm a senior data scientist, and today what we're going to see are these three main topics. So, what I want to show you is what is Project Thoth and the integration that we provide in the frame of GitOps principles and all the way the developers and the tool they use in their daily work. The second part will be focused on how do we basically monitor and observe a service that is deployed on OpenShift in a multi-namespace, and how do we define what is called the service level indicators, service level objectives that we define. And the third part will be basically showing how do we use these metrics, all these indicators, to help us improve the system and improve also the user experience for the service that we provide, which is basically what we do with the data-driven engineering in this case. So let me start introducing Project Thoth. So Project Thoth is an open source project, and you can find it on GitHub under the Thoth station. And one of the goals of Thoth is to help developers in the selection of the dependencies, depending on the requirements that they have. Just to give you some of the example, let's imagine that I'm a data scientist and I want to train my model, and I should select some of the dependency, for example, TensorFlow, but I don't know in which version should I use it and which type of runtime environment should I use, because these are information that is not part of my domain at the moment. So what I want to do is just to train. So if you think of having a service that could answer the question like, what is the most performant software stack that should I use in order to train this model? And should I use a GPU? Should I use a CPU? Or this kind of questions. Another example might be, for example, I need to deploy this model or this application, Python application in this case, and I want to know which is the software stack that does not contain any CVE or any vulnerabilities. And I don't want to have any of the libraries that might contain some of them. And this is also another question that Thoth is able to answer. And what we also target is that these kind of questions, so if some user has some requirements in terms of this performance on security, for example, there is a service that basically would offload this work, because it will be able to answer this question directly. So the developer or data scientist does not need to worry on that. What needs to worry is the work and, for example, the model that you need to create for your AI application or your Python application. And why I mentioned the Python ecosystem, because Thoth is currently targeting the Python ecosystem, and the goal is to have, of course, a recommender system that developers or data scientists can use to receive advices or recommendation on your software stack. And not only, you will see also what the integration that Thoth created might help the developers in general. So these are some of the questions or some of the way that Project Thoth aim to help the developers. So if you think of dependency management, nowadays there are many types of release or many types of new projects that are released. And some of the question might be, for example, if I should use some new project for if it's well maintained or if it's a good health, if it's a good health in the community. So this kind of question can be also answered by Project Thoth. But these are some of the ways that we can help. So some of them I already mentioned. For example, if I want to have an application deployed and I need to build that image with that software stack, then Thoth is able to verify that each of your library that you are using do not contain any CV and any vulnerability, and provide you with the software stack that basically avoid this kind of issues. If we talk about the data science domain, as I said, there is, for example, the case of having the training on GPU or CPU, and you want to know which is the most performant software stack. Or in the inference part, if you want to deploy, for example, on some edge devices and you have different combination, you don't know, for example, which software stack is more performant for the different case. So this kind of question will be answered by Project Thoth. Let me move ahead. This is one of the example of the metrics, let's say, that we collect. For example, as I said, we started focusing on the Python ecosystem, and we look at what is happening mainly on the PyPy index from this slide. So to see how fast or how many packages are released per day, because this is very important for the system to learn on this type of packages. So as I said, Project Thoth tried to answer this question for the selection of the software stack. So the first thing that needs to learn is which Python packages exist, and it needs to learn observation from these packages. So we need to know how many are released in order to, for example, target a certain level of packages that needs to be learned, we said, every day. So we can always be up to date for the user to receive the most updated software stack, of course. So these kind of metrics are one example of indicators that you need to take into account for your, in this case, for Project Thoth, that might help in some decision, also in terms of investment in I don't know, new resources that are required. So in this way, when you take the decision, you are using the data-driven engineering way in order to select to make some decisions. So how does Thoth is able to answer of this question? This is a list of observations that are stored in the knowledge graph. So Project Thoth has different services and components that, first of all, start to collect the knowledge regarding all these packages, as I said. So there are different type of observation. Let's try to go through some of them. So first of all, when you have a package, one of the first things you want to know is how my dependency graph look like, and if that package can be installed on my environment. For example, if I have Fedora or if I use UBI images, I need to know if that package is going to be installed correctly and if I can run it correctly. And this is what one of the questions that this component called solver try to answer. So there are different types of solver that Thoth contain, and for each of them, we want to learn if that package is going to be installed or not. So as you can see, this kind of observation allow Thoth to provide the recommendation in terms of the packages that best fit your runtime environment. Second is the performances. So on the application stack level, Project Thoth has these two components, if you talk about the performance, there are Dependency Monkey and Amoon. Dependency Monkey is a component that is able to browse through the dependency graph and create combination of the dependencies that are available for a certain package and submit them to Amoon. Amoon is a service that is able to run some specific performance indicator, we call, so some specific script that needs to be run in order to gather performance. And we do this for different type of ML frameworks, so TensorFlow, PyTorch, and we can do that also for other types of layer in the software stack. So if you go at the Python interpreter level, for example, and this kind of observation are all stored in Thoth in order to provide recommendation in terms of performances for your software stack. So should I use PyTorch or TensorFlow for this kind of application? Is it more performant to do computer vision with this kind of library or another type of library? So that's why these observations are stored in Thoth. At the package level, we collect, as I said, things related to security. So we have CVE that comes from one specific source in terms of the Python ecosystem. And we also created some security analyzers using some packages like Bandit that are able to identify vulnerabilities inside the packages. And we store those information and in order to be used if the user has some requirements in terms of security. Also, there is a package extract. So we are also able to gather observation regarding the ABI. So in order to learn if that package is going to run or if there are any ABI incompatibilities that would prevent that application to run on a specific environment. And this is the third class, so what we call source code meta information. So if you think of all the packages that are available on open source, this kind of observation are focused on the health of a project. So we want to know if should I invest in that project because it's well maintained, if the time to close issues or the time to review pull request is something that is well done in that ecosystem. And this will basically allow Thoth to provide observation recommendation on which kind of package should I use, because not only the package works correctly, but also does not have any security, but can also have information regarding the health of a certain project. And I won't spend too much time on this, but how do we provide this knowledge? So Thoth is a service that, as I said, is deployed on OpenShift and is deployed on different namespaces, which focus on specific tasks that are able to run the services that we need in order to gather observation. And then we have our advisor. Advisor is the core component that is able to resolve the software stack and provide the recommendation to the user. And advisor is based on reinforcement learning. So use all this knowledge that we collect and provide and continuously learn on the new observation that comes from the other services that we use to collect observation and provide the most updated software stack depending on the user request. If you are more interested in this, I can show you later some of the place where you can have a look for more details regarding Thoth recommendation system. So we looked at a definition of what is Project Thoth and what we collect in order to provide the recommendation. Now we are going to see how do we provide this recommendation. So what kind of tools are created and why there are all these different type of integrations. So let's start with the CLI tool. So let's say that I am, in this case, a developer and I want to start my application and I want to have some recommendation with the most performant software stack. So Thoth created one of one integration that is a CLI tool, which is called the Thamos, that you can basically install simply doing pip install Thamos in Python and ask for Thamos advice. And this kind of integration is able to provide with the pip file lock that you can install and use for your application. Why I said pip file lock? Thoth is also very focused on the dependency management work, and it cares a lot about the possibility of reproducible build. So if you want to share your work, if you're a data scientist or if you're a developer and you want to share this kind of code, you need to provide not only the direct dependencies, but you need to have a pinned down software stack that show everything related to that to the software stack. So not just the direct one, but also the transitive one, the ashes. And this is one of the example and why we started to use pip and similar files to provide to the users. The second integration is more focused on the data science world. So if in this case, I am a data scientist and I'm starting to work on my Jupyter notebooks, or I work on Jupyter Lab notebooks. And we want to provide a tool that basically offload or make easy the life for data scientists that do not need to worry on performances or dependency issue, because there is a tool that can help them in make this easy for them. And that is what this kind of extension in Project Thoth has been created. So if you use Jupyter Notebooks, there is what you see right now in this small video, which is called the Jupyter MB Requirements Extension, which is for Jupyter Notebooks. And we recently also released one for Jupyter Lab, which is called Jupyter Lab Requirements. And as you can see, it's very easy to use, where a data scientist can select some packages that are required for the software stack and then just save them and install them. In this way, when the dependencies are created, are directly stored in the notebooks. And why we want to do this is because we want to provide a way to make easy the reproducibility and shareability of the notebooks. That is something very important if you want to allow others to reuse your work. Another type of integration is we have GitHub Apps. One of them is the Cechetta one. So it runs as a check run. Every time you open a pull request, there is a Cechetta that is able to ask Thoth for any advice on your pull request if there are any changes on your software stack, and give you some suggestion or recommendation on what is important or what type of recommendation or of justification are provided for your software stack. Another important integration that we have is bots. As I said, we want to reduce actually the work of humans in terms of this kind of problems related to dependencies, so that they can basically focus on other more important topics. And Cechetta, or Cechetta in this case, is an application that you can install on GitHub and is able to keep your dependencies up to date. So as I showed at the beginning, there are different ways that we want to help, and what Cechetta is going to do. If you imagine starting working on your Jupyter notebooks or on your local environments, and then you push something to Git. So if you think about the GitOps principle, the software stack that is stored on your GitHub repository then is going to be basically maintained by this bot in terms of dependencies. So that imagine that there is a CVE appearing at some point related to the software stack, then this service is, or this bot is using Thoth service in order to provide you with an updated software stack that eliminate that dependency that which has the vulnerability. And in this way, you don't need to worry about this kind of problems. Regarding deployment or using of images, source to image is well known, and Thoth wanted to provide an integration that can help also in this kind of tool. So if you imagine that I'm starting to build my image in order to release it on QA, and so that they can be used to be deployed on some environment, then the added value of having something like Thoth is to make sure, for example, that your environment is specifically targeting some environment. So if I ask for CUDA or some specific runtime environment, and the system is not using this kind of runtime environment, then Thoth, for example, will make the build fail because there are checks which are not satisfied. So you're asking for a specific environment, but you miss, for example, the CUDA libraries. And in this case, this would basically help everything in a pipelines and to automate all this work. And the last thing is something that we recently also released, which is an optimizing deployment pipeline. And what we want to do in this case, so Thoth is able to provide you with an optimized software stack, but in some cases, when you want to deploy the software stack, you need also some configuration that needs to be added to your deployment. So in this case, Thoth is not only able to give you the software stack, which is optimized for that runtime environment, but will give you also some patch for your deployment that you need to use in order to reach that kind of performance that that you need to use. And as you think in general for GitOps principle, this is something that can really help in providing the best recommendation in order to have the most optimized software stack and the most that need to run on the most optimized runtime environment, which requires, in some cases, some specific configuration. So this is just a recap of what I just showed you in terms of the integrations. And as you can see, they cover basically all the tool that someone can use or that can use in if you want to deploy on a cloud environment, or if you want to work of your notebooks. And this also helps a lot in terms of GitOps, if you think, because Thoth is able to help you on your repo where you have your code, but also at the same time can help the DevOps on the selection of the type of deployment that needs to be created in order to run that application on the cluster. And how do we provide this recommendation? So this configuration file is the only thing that is required by Thoth, beside the software stack, of course, that will help or that the user can use in order to provide inputs in terms of the requirements that it has. For example, if you think in terms of recommendation type, Thoth has a different type of recommendation that can be provided. So as I said, if you want just your latest and greatest software stack, that is something that you can ask in terms of recommendation type. If you're interested in having a security recommendation because you want to deploy in production,
I think we lost Francesco. Chris, can you hear me?
Looks like he just lost internet or something. Screen's still there. That's impressive.
Okay, so I don't know if he's gonna make it to.
Yeah, I would say give him a second. He might be reconnecting, or let me try and ping him. And he's back.
Yes, I'm really sorry. Something
Nope.
happened with Twitter.
No
The internet always be the internet.
Yes. Sorry. So I'm back. I was back here. I hope when I stopped.
I don't see your slides.
See why? What about now?
There you go. Loading present. There we go. Yep.
Thank you. Thank you very much. Sorry for the
for a while when you disconnected, but good job. Let's continue forth.
Very much. So, as I was saying, in order to interact with the Thoth services, you need to provide also a configuration file, which is stated in this Thoth YAML file. And in here, you can basically describe the type of recommendation that you want. Sorry. So when we talk about recommendation type,
slides.
yes?
I don't think your slides can be seen. You can see your face.
Watch the presentation.
Let's try again. I don't understand.
Come on, Blue Jeans, you can do it. I believe.
There we go.
Can you?
All right.
So
Can see it.
Not sure why. Okay. Perfect. So as I was saying, in order to interact with the Thoth service, there is a configuration file, this Thoth YAML file that needs to be provided. And in this configuration file, you can basically select the runtime environments that you want to use for your application, and the Thoth service will use in order to provide you with the recommendation. In terms of recommendation types, there are different kinds. So if you want the latest and greatest software stack, you will just use the recommendation type latest. But if you are interested in something like security, so you don't want to have any vulnerability or CVE that going to your production environment, or you want to have the most performance software stack because I need to run it for my training or on the inference, then you would use different type of recommendation. And this is just one of the example. You can provide more than one runtime environment if you want, if you're interested in different type of recommendation. And here is also another important thing to notice, that the requirements format is not, let's say, only for pipenv, but Thoth is able to deal with all the dependency management tools that are available in the Python ecosystem. So we don't constrain anything in terms of what the user want to use, but we are able to provide the optimized software stack or the recommended software stacks in any case. And this is another feature that we recently introduced. The use of the overlays, for those of you that are familiar with ArgoCD, or the use of overlays is something that is important if you think of deploying different types of application on different environments. So imagine if instead of having this name Fedora 33 and UBI8, you would have different runtime environments which are called test, stage prod, or training inference. In this case, you can ask Thoth for advices, and different type of software stack will be provided for the different runtime environment that you selected that would match the overlays that you would use, for example, if you think of ArgoCD in terms of deployment of your cluster, in your cluster, then this type of recommendation can be provided for the deployment. And in this case, the image that is created out of these runtime environments would be selected for this kind of environments. So now that you had an idea about Project Thoth and the different type of integration that has been created, what I want to show you now is the service level indicators, or the definition of these metrics, and the importance that they can get in big services that needs to be created in order to help not only the developers, but also who take the decision in terms of if you think of investing in some new resources, you need to also have a way to make decision out of this data. That is the goal of having data-driven engineering. So the first definition, if you want to provide a service, you will be familiar with this kind of a definition. So there is a service level agreement, service level objective, a service level indicators, and this definition are important in terms of the service that you want to provide. Some of the examples that you can have are, for example, the latency, the availability. You want that service to be available 99.999% of the time. And in order to state that in your service level agreement, you need to have indicators that help you verify that this kind of service is able to reach that kind of objective, and so that you can provide that kind of agreement. But in order to, why this is also important is that if you have anything that needs to be improved in the system, these are indicators that immediately help you identifying issue in your system that basically trigger all the task and work that needs to be done, or the definition or the request for new resources in order to get to that objective that you want. And this is just a general introduction of the service level in general. But what is important is always to have all these metrics. You need to observe what is in your system. And in case of Thoth, we created several type of metrics that focus on the different layers. So we get the one from OpenShift in terms of the cluster, but at the application level, we have everything that is used in Thoth. So all the services needs to be monitored, and we need to define some service level indicators in order to make decision on what needs to be done in the project. And this is just a list of the technologies that we use. Of course, we run on OpenShift, and we use Prometheus and Thanos to scrape all our metrics for the different components, and we see every metrics in Grafana. We also set alarms out of this in order to make the team aware of anything that is going wrong in the system. We also use some tools from the Open Data Hub and U and Superset in order to not only use these metrics, but out of these metrics, we make analysis of them. We combine them in order to define these service level indicators that are really used in order to make decision on what needs to be done in your system. And Kafka and Argo are two of the technologies that are also used in Project Thoth. Kafka, we use it for send or any event that is happening to send messages across the components. And Argo workflows in this case is what we use in the services. I introduced this kind of technologies because the service level indicators that we define are, of course, related to the type of technology that we're using. And this is one example of some scenario that can happen in Thoth. So imagine on the left side, you have each of these section basically describe one namespace or one cluster where we have Kafka, for example, and where we have the different services that are running. So if you think, starting from the left, there is any user using any of the integration and they ask for a Thoth advice, then in that case, our user API would use Kafka messages that are sent to a central component, which we call investigator. This kind of component is able to react to all the events that come through it, not just for the user request, but also for anything that is happening on the learning side of Thoth. And based on some condition, it would basically decide what needs to be done. In terms of advisor, as you imagine, what is going to happen is that the advisor service or the advice workflow, in this case our Argo workflow, would be scheduled. And inside of Argo workflow, there will be other tasks that would react to other events and make the system continuously work on any user request. And why this is important, if, as I said, you need to know the type of technology that you're using and define some specific metrics for each of them, because in that way you can define some indicators out of these metrics. And if you think about the Argo workflow, for example, you can get some of the interesting indicators are the percentage of successful Argo workflows, or the latency in terms of these services that are used, in terms of these Argo workflows that are run. Another example is the learning one. So as I said before, we have this still with investigator central component that react to what is happening or to the events that are taken from Kafka. And if you imagine that there is a new release of a package, what happens is that there is a component that would send in this message, and based on that message, the investigator would schedule different type of workflows in order to gather the observation that are required for Thoth to provide advices. And this is all automated inside Thoth, and therefore you need to have a way to monitor what is happening and to immediately identify if there is any kind of service that is reducing your objectives, and in that case decide what are the actions to be taken, if more resources are required, if some technology or some specific components is not performing well, then we need to basically take decision on putting some resource or some of the team working on that. So in this way, we can really have a way to target what needs to be prioritized using the data that we have from our system. And some of the example of the service level indicators that we created are basically, of course, the quality of the integration. So you want to know which of the integration, we have many type of integration, and we want to know which of them is most used. In this way, we can decide or we can prioritize which of the feature we need to focus on first. The time that are spent on this type of integration. So you want to know how much time the service from the initial request from the user to going back to the user, how much time is taking, if we are if we need to improve or change something in any of the components in order to make this indicator lower in this case, if you talk in terms of latency. The learning rate, so as I showed, Thoth needs to learn on different types of runtime environment, so different types of solver, and this requires a learning rate that basically needs to be faster than what is released, for example, upstream, in order to gather up the observation that we need in order to provide advices to the user. In terms of backend services, in this case, we talk about these Argo workflows, and we need to know the quality and the latency, so the percentage of successful one, the time that they are, the time that is spent on each of these workflows, and their acceptance rates or recommendations. So if you think about some of the bots that keep dependencies up to date, then we want to have also an indicators in terms of acceptance rate. So if we provide this kind of advice, then are they accepted? And if they are accepted, we want to know that, because in this way we can also prioritize some changes or something that would improve the user experience, and why, for example, the acceptance rate is not so high. And then we move to the last part. So you had an idea of what is Project Thoth and all the different integrations. And then we move to the service and metrics level. So what we need to gather in terms of observation to create these indicators that help basically the team taking decision and setting objectives in terms of what the system needs to do in a way to have these agreements that you can provide to the users. And this is some example. If you go to the left side, you see that there is one Grafana dashboard. This Grafana dashboard is basically looking at the number of workflows that we are running on the namespace in a certain namespace. And in that case, there was too many workflows scheduled at the same time, and the system was not able to deal with all of them. So we had to reduce in that case, because there was a problem with some of the component. In that case, we had to reduce the number of workflows in order to keep the system running. So we didn't want to stop the system, but we could reduce a bit what was doing in order to using this data-driven engineering solution. And what you see on the right side instead is, in that case, we were running several of these workflows in parallel in the same namespace. And what we realized is also that actually the OpenShift namespace was able to run even more of that. So in order to utilize at the maximum all the resources of that namespace, we basically use this data to decide what needs to be done. Regarding the learning rate, so this is one example. There are two types of learning in Thoth. We have the solver one, which are the basic for any type of recommendation. And then we have, for example, the security one that needs to be also included in order to provide the security recommendation. And there is a minimum service level objective that we set. This type of chart, oh, I forgot, but the measurement unit in this case is related to the minutes. So this is what is happening, how fast we are learning per minute. So the scale on the y-axis is basically the number of packages that we learn per minute. And that is what we target, for example, is at least 10 packages on average on a certain period. In this case, we look at a weekly basis, but we can see if the system is able to, not only the application, but in this case, we can also see if there is some issue on any of the components or on the network or whatever is happening in the system. But these are important indicators that we help the team basically immediately identify if there is something that needs to be changed in the system. This is something that we recently also changed. So that pull request I showed you before, where we increased the number of resources because we could increase them, basically led to an increase on the number of packages that we could learn per day. So to think about what was happening before this period, now we are basically able to almost double what is happening, what is learning the system. And this is another example of how we use all this data to easily identify something that can be improved in the system or that needs to be solved. And this is one example where this is the quality of the workflows. So each of these plots basically show you the percentage of successful workflows that are happening per day for each of the services that we have. And in this way, we can see immediately if the successful workflows is too low, means that there are some failures or there are many failures. For example, if you see when the percentage is too low, that basically show some problem in some of the components. And this helps us immediately identify if there are errors that the system is encountering and that the team needs to take care of for each of the services. This is what they say in terms of latency. So we can see for each of the services that we have, or for each of the components, sorry, in this case that we have, that the latency that is taken for each of them. So if on the x-axis you see the time, and on the left side axis is the latency that is divided in different sections or heat maps in this case, and each of them show the percentage of workflows that fall in one of these buckets. So if you see that the system is basically going up on the right, there are some of the workflows that are taking less and less, and this will show us that the system is getting better in terms of speed of execution of these workflows. And in this way, we know if the system is able to provide also a certain service with a certain latency. In terms of integration, as I said, we have all these different integration that I explained before, and we also target or we also monitor their use. So in this way, we can see which of them is needs to be prioritized in terms of features that we want to introduce because of the use that the user are making of these integrations, and also to understand why others are not used, and identify improvements that needs to be made in order to get also the other integration used. In terms of quality of recommendation, we also focus on each of the recommendation that Thoth is able to provide. So in terms of the software stack, we also provide the recommendation. I hope you can see is sorry for if it's too small, but what I want to show here is that every type of recommendation that we provide is also monitored in order to see if we are providing the correct results to the users, and if also the system has any issues inside it. And here, for example, you can see that in some cases the system is failing because of out of memory, and that means that, for example, the service requires more resources, and this is very important for us to immediately know if we want to provide a better service, of course. With that, I think I can conclude. This is some of the way that you can reach us. So we have an open channel on Google Chat that everyone can join. We have a ThothStation YouTube channel where you can see everything that we do. There are all our Scrum and demos that we collect there in order for everyone to be able to see. We have a website, the ThothStation Ninja, where you can find many documentation regarding Thoth and all the components. If you are interested in the recommender system, there are videos on YouTube. There is also a description of the website. And we're also on the Twitter. And of course, our project is completely open source, and you can find it on GitHub. And with that, I would like to thank you for attending, and I'm open to any question.
Right. Thank you so much, Francesco. So this is a really great presentation, and we do have one question that I've seen. So is this integrated or a part of Red Hat Insights? That's a question that was asked.
So you mean if the project Thoth is inside the Insight? That's the question?
Correct.
No, Project Thoth is a community project, open source, is part of the AI Center of Excellence, and what the goal of what Thoth wants to do is to recommend the software stack. So there are all these different integrations, and there is no, I mean, at least not something that we do with Insight at the moment, not inside Project Thoth.
Okay, thank you. I don't see any other questions. Chris, are there any other questions from maybe Twitch, YouTube? I guess not. So, Francesco, we can just wrap this up. So we don't have any other questions. Great. So this was a really great presentation. Thank you so much. And I just want to say thank you to Chris also for
Thank you, Chris.
using this session and making the live stream seamless. I know we had a few hiccups here and there, but hey, that's technology. It's all right. Thank you everyone for watching this session. And with that, I guess we can close it up. So have a good rest of your day. Bye.
Bye bye, Beverly.